So good morning. Welcome to the next OpenCloudification webinar, 2024, the second full year of OpenCloudification, and with quite a lot of new insights and new developments that we would like to share and show you. Let us first start maybe by giving a bit of a retrospective also on some of the things that we've been doing. So as I said, we've ended 2023 with a couple of look backs on what OpenCloudification has been doing. And from that, we still want to make sure that, of course, OpenCloudification continues to support companies in their focus towards applying new technologies and specifically looking into potential clouds, which is quite common, as we also discussed at the end of last year. So quite normal, but then the way to do that is sometimes a bit of a challenge. So what we within OpenCloudification would like to do is to support you with this transition, making sure that you can apply open source capabilities if needed as well, that you find also the necessary tooling and materials for this, and that you can also learn from the experiences of others and of some of our experts on where to go to. And then specifically in terms of cloud native technology, open cloud technologies is what we will be mostly looking out for. As also will be the case for today, we'll be trying to apply some of the state-of-the-art research in the day-to-day activities, helping you with providing some guidance towards some of the existing tools and some of the ongoing developments in tooling. And of course, things that we are doing here, webinars, but also more and more workshops during the course of the year. And so what you can still expect from us is to receive some further practical guidelines in the form of some white papers and some documentation as such. In between, let's say, the last time that we have been working and today, we have also been able to start with some new activities. In this case, we announced it already quickly the last time. So new activity, which is called cybersecurity for micro enterprises and small and medium-sized enterprises, where we know that there's actually quite a lot of challenges with those SMEs. And especially also when companies are looking towards using cloud technologies or migrating into cloud, that is definitely one of the challenges that we see that's popping up quite heavily, because many of their concerns are now being managed by the cloud service provider, but sometimes it's usually it is a shared responsibility, so it is something to take care of, and especially for small and medium-sized companies, we do recognize and we see that that's sometimes a bit of a challenge. So many companies are seeking this are seeing this also as a challenge. They are basically taking this on a day-by-day basis, just watching over the next cybersecurity challenge that pops up. So what we are trying to approach here is making sure that there is a proactive approach, and that if you have maybe your development of your cloud activities inside of an environment like any of these two, but you're still very much looking towards making it much more secure, then you can reach out to KISME. KISME is basically a coordination done by ELSEC, and we execute it together with a number of European partners. It's funded through the European Commission activities, and the main goal is that we can actually provide you with some tooling, but also with advisory and with some direct focus to improve the cybersecurity maturity of your company, of your organization, and therefore also, of course, of your cloud activities. So do reach out to us on this, because we actually have the mechanism available to offer you some of those capabilities at a very low cost or at zero cost even. And get you started with some specific tooling in order to make sure that happens. We can also help you out in doing a preliminary assessment on where you are currently in order to help you doing the migration. And then another activity that we'll be talking about very shortly is sort of a sister activity, if you want it that way. It's called KISD, and that's really standing for supporting companies which are there to figure out how to do pen tests. So if that's also something that you might require, we actually have some financial means available for external companies that can help you doing those pen tests. For instance, also for your cloud environment, of course, with the support and link to what your cloud service provider can offer you. So a couple of these activities is what we are also starting with. In terms of open cloudification, we have quite a number of activities planned for 2024 and beyond. These were some of the ones that we have been discussing at the end of 23. So today we will be starting with basically an activity on open sourcing. Probably tomorrow we'll be having also a session on cloud key management. And then throughout the first half of the year, we're still working on the programs and trying to find the right speakers for this. But here are a couple of the topics that we have suggested that we will be working on. So looking forward in getting you to participate in some of these going forward as well. And if you would like to reach out to us, then please do so with some concrete ideas or topics, or with some additional suggestions for new developments. Any of the parties that you can see here in this case. So as you know, we are doing this activity together with some partners such as the Beacon, based in Antwerp, usually when we have physical activities, and also when we have activities directly related to working with the Beacon members, we will do it in Antwerp. And our other partners based in Ghent, in this case IDLab IMEC, and Merlijn Sebrechts from IDLab IMEC is here present together with us, and he will be guiding us through the use of open source and basically the some of the baseline concepts and ideas behind this, but also some of the practicalities and things you might need to look out for if you would apply open source technologies. Merlijn, you want to take it along?
Yes, I think I still need screen sharing permissions.
No, you should be having it.
Okay.
Yes, we can see your sites.
All right, that's great. Let me just resize my window here. So, hello everyone. As Ulrich said, I am Merlijn Sebrechts, and I'm going to give an introduction to open source. First of all, I wanted to give a little context as to why I'm giving this presentation. I'm a senior researcher at IMEC, and I teach at Ghent University. And throughout both as a hobby and as part of my research, I interact a lot with open source communities, and I use a lot of open source software. I've recently been elected to the Ubuntu Community Council. I've also worked with Snapcrafters, and I've been a Charms.reactive core team member. And throughout these activities, I've had a lot of experience with building open source software and interacting with open source communities. And so I wanted to give you a very, very broad overview of open source software, a very broad introduction. I'm going to start with just what open source software is. Then I'm going to talk from a personal perspective of why do people, often volunteers, create open source software? Why do people like me want to spend their free time to actually develop very valuable software for free? And secondly, I'm going to talk about why companies are interested in creating open source software, and specifically companies that are not in the business of creating software, why they want to create open source software. Then we'll have a break, and then I'll talk a bit about the business models of companies that have made it their business to create and sell open source software, because often it's very useful to know why certain companies build the open source software that your company uses or that your company is going to use, so that you can have some strategic alignment with the goals of the company creating this software, so that you know that the way that you're using the open source software isn't against their business model, for example. Then I'm going to do a deep dive in how open source licenses actually work. And finally, I'm going to give a little bit of a broader context, a broader insight into what is it that makes open source software so special. Why is open source software one of the only fields where you see billions of dollars invested in developing stuff that is given away for free, basically? So first, I'll explain what is open source software. So open source software is about sharing the design plans of software, sharing the source code of software, using an open source license. And this is something important to keep in mind. Open source software always means that the software has an open license. I can't just put my code online and tell everybody this code is now open source software. No, there is a legal framework surrounding making something open source. And so, very brief introduction, a software license. Well, a software license is basically the end user license agreement. It's one of the biggest sources of lies in IT personnel, because every IT person says, yes, I've read this license, I accept it, while in reality, nobody really reads these licenses. But this is basically the legal mechanism to create open source software. Here you see a commercial license, the Adobe Software License Agreement. But for open source software, instead of having this commercial license, you get, as a user, you get from the creator of the software, you get an open source software license. So a license is a legal document that describes how users of software can use the software. Some licenses are paid, like Microsoft Office. Some licensors don't have any cost, like, for example, Fortnite, it's a free game. And some licenses are open source, like, for example, VLC Media Player. But what makes a license open source specifically? Well, the answer is not really a what, but it's a who. Because the Open Source Initiative is a nonprofit created in 1998, and they define open source software, and they define what licenses are open source. They have a trademark around the term open source, and in order to be able to call your software open source, it needs to use a license that is approved by the Open Source Initiative. It basically means that the license makes the code freely available to users of that software. The users of the software can share the code and share the software itself freely. They can modify the software and share their modifications, and they can run the software for any purpose. If a certain software license checks these 4 boxes, the Open Source Initiative will, there is a process in order to make it certified. The Open Source Initiative will certify that license as open source software. And so it's very important to make the distinction between visible source and open source. There is a lot of source code that is available to read, but that is still not open source. And a great example of this is the Unreal Engine. The Unreal Engine is a very popular game engine. A lot of very popular games are built on top of the Unreal Engine. And if you go to GitHub, you will actually be able to see the Unreal Engine source code. That's because the Unreal Engine is visible source. Anyone is allowed to modify the source code, and anyone is allowed to distribute modifications. However, it is not completely free in order to distribute modifications and in order to use the Unreal Engine. It is free to use until you have 1 million gross revenue in your business. And after that, 5% of the royalties of your game go to Epic Games, which is the creator of the Unreal Engine. And so that's the difference between visible source and open source. Open source not only means that you can read the source code, but you also have to be able to freely share it with anyone, modify the software and share your modifications freely, and run the software for any purpose. So, a personal perspective. Why do individuals contribute to open source software? If you look at popular open source software such as the Linux kernel, then you see that often around 20% of contributions are being done by volunteers. So why do these volunteers actually spend their time to build open source software? One of the main reasons why I really like doing it and why I really like spending my free time is because it's incredible fun to create and develop open source software. I've been developing open source software right now for 12 years, more or less. And I've made some lifelong friends developing open source software. I've also been able to see the world because open source software is often developed by a team of both volunteers and paid developers from all around the world. And these companies building open source software, they often pay for volunteers to come together to a certain conference, to a certain part of the world, come together and talk about developing the software and help developing the software. It also really helped me personally because it was an incredible learning tool. I've learned so much from developing open source software. And in fact, the track that I am on, the professional track that I am on right now, as a researcher now at IMEC and a teacher at Ghent University, this all started with a PhD. And I've actually gotten this PhD because of my experience with open source software and because of all the skills and capabilities I learned while developing open source software. Another reason I really like it is because it's really fun tinkering with such large and complex software systems. I was the kind of kid that when I was very young, I took old computers and hit them with hammers until they broke open, and then I started to look at all the little components, and when I got a little bit older, I learned how to use a screwdriver, and I learned how to open computers without breaking them. And I really liked just tinkering with technology, and open source software is some of the most world leading technology that you can just freely tinker with in your free time. Another reason is because it's very meaningful. Meaning is very important in your life. And for me, creating open source software is one of the things that gives my life meaning. I'm building impactful software that runs on Mars rovers, that runs on satellites, that runs on random schools at the other side of the world. And I'm all doing this like initially in my free time. Not as a professional developer. Initially, I was even just a student. I didn't have a professional software development degree, and still I was able to create software that impacts so many people and that does so many cool things. Then another reason is that it's sustainable. And that's also something that's really interesting to me personally, is that we're building something for the next generation. It's not that we're building software for one company and when that one company disappears, then the software disappears. No, you have like all this modern digital infrastructure. The reason why it's so easy to create an Android app today is because we can stand on the shoulders of giants of the past. All this infrastructure that is being used in order to develop an Android app today, it's all the foundation of that infrastructure. It's all open source software and often projects that have been created maybe 20, 30 years ago and that are still being improved and maintained today. Curl, for example, is a piece of open source software that is on every single device in the world, and is often like at least 10 times on every single device in the world, because every single application uses curl in order to download files from the internet. And so anytime you have an application downloading files, you can be 90% sure that it's actually using open source software in the backend that's like 20 years old, that's specialized in solving the problem of downloading files from the internet. And that's the reason why developers today don't really need to know how TCP/IP works, how all the different internet protocols work, how HTTP works, in order to actually download a file from the internet. No, that knowledge is already embedded in a piece of open source software that the previous generation gave to us and that we can build on top of. And then finally, it also democratizes technology. This is something that's very important to me personally, is that technology often is something that is difficult to access for a lot of people in this world. Also, often a lot of the most popular platforms are created for the common denominator person, for like the average person. And so there's a lot of people in society for whom a lot of the popular software that is being created does not serve them. So you have a lot of open source pieces of technology that are being used, being created, and being improved by these people who have been less cared for by popular commercial alternatives of software. And so it makes sure that technology is available to everybody in society. So then the second question is, I'm a volunteer. I just create software in my free time, but there's also a lot of companies building open source software. In fact, most of the open source software is primarily built by companies. So why do companies actually do this? Why are companies creating software and then giving it away for free? Well, you can divide the reasons in two main categories. The first category is that software is not the main product of the company. The second category is that open source actually helps them create and sell software. So in the first category, software is not the main product. The first reason I want to give to you is to take on the big guys. It's a pattern we see a lot in open source software, where you have a single very big player that is dominating a certain market. For example, Google. Google has amazing search functionality that they built completely in-house that is dominating the market. And then you have a whole bunch of smaller players that also have search functionality, that also offer search services, but they don't have nearly the budget of Google in order to invest in search software. And so that's why all these other companies, they all come together and collaborate on common open source software in order to implement search engines. And so even though the main search infrastructure of Google is completely closed source, most of insignificant parts of the search infrastructure of all of Google's competitors are open source, and many of these competitors actually share the same infrastructure. Hadoop, for example, is a big data processing project that was created by Yahoo as a piece of open source software in order to be able to build a search engine that can take on Google. Another example of that is OpenStack. You see that Amazon is the big player in the cloud. And a lot of the runner-up cloud players, for example, IBM and Rackspace and a lot of the regional data centers, most of them all use open source software that they develop together collaboratively in order to be able to take on Amazon. because by themselves, every single company would not have enough money in order to invest in the software, in order to create a product that is competitive. But if they all work together, they are able to create a product that's competitive. Vulkan is exactly the same thing. Vulkan is a graphics API in order to have a game talk to the GPU. DirectX is Microsoft's solution for that. However, you have a lot of other companies that all create devices that they also want to run games on. For example, Nintendo and Sony, Android. All Android phones can run games. All the other competitors to Microsoft Windows and the DirectX offering for running games, they all use a single open source API, which is called Vulkan. Because in order to be able to compete against Microsoft, they need to band together. But they can't give away everything. I've talked about companies for whom their primary selling product is often software or services. For example, search engines. A company that creates a search engine can't just build the complete search engine as open source and give it away, because then somebody who is not developing that code can just take that code and run it for free, and have a much cheaper option in order to compete with the company actually developing the open source product. So how do these companies do that? How do these companies balance that? Well, you see that a lot of these companies are both collaborating and competing at the same time. And they do that by having a shared base of common functionality as open source software. And then on top of that open source software, they implement vendor specific features, and they compete with these vendor specific features. And then after a few years, after every single vendor has the exact same features, they come together, they standardize those features into an open source product, and they build their own vendor specific features. And that's why you see a lot of these open source products, even though they don't implement the complete functionality, each year the open source foundation grows in functionality, because once every competitor has the exact same functionality, there's no point in maintaining that functionality by themselves. It's better to just put that functionality in the open source software so that they can spread that cost over all competing companies. The second reason why companies are creating open source software is because they want to improve or they want to sell other commercial products. For example, a very, very prominent example of this is Google Chrome. Google Chrome is basically Google building their own market by creating open source software. Before Google Chrome existed, web as a platform to build apps for was in a very bad state, mainly because the web was dominated by Internet Explorer, which had incredibly outdated APIs, which made it very hard to build performant and featureful web applications. Google wanted to change this because Google's entire business model at that time was around advertisement. But in order to have more advertisement revenue, they had to have more people using web browsers, using web applications, and more people building web applications. However, a lot of people that actually wanted to build web applications, that wanted to deliver certain software functionality to their users, they couldn't do that because the APIs for building web apps were so bad that there are a whole series of pieces of software that would never work as web technology, simply because you could not develop them because the APIs weren't there. So what Google did was just create a free, open source, and incredibly performant browser. In a very short period of time, they increased their market share so much that Microsoft felt threatened in their position. that Microsoft had no other option to start innovating again in their browser, start building great web technologies again. And so as a result, web as a platform took off. A whole bunch more people started using web applications, and many more companies started building web applications, and that increased Google's market. That's why Google is still developing Google Chrome in order to create a very vibrant market for all their web applications. Now it's more than just advertisement. They also have Google Docs, for example. Google Docs is a very great example of a piece of software that would have never worked if Google Chrome wasn't invented and if Internet Explorer in its state in 2000 was still the state of the web today. So there's a lot of other examples of this. Google develops Chrome in order to sell Google Workspace and Google Advertisement. Qualcomm and Intel, they create Linux in order to sell Intel CPUs and Qualcomm systems on a chip. Because in order to sell hardware, you actually need software to run on it. And the cheaper the software is to run on it, the easier it is for people to actually buy the hardware. Same with Android. Android is being developed by Samsung in order to sell their phones. Android is also being developed by Google in order to sell the Google Play Store. And so there's a law of technology behind this. And the idea is that you commoditize your complement. So a complement is basically a piece of technology that is always bought together with the product that you are selling. A piece of technology that is required, that customers are required to have in order to be able to use a specific technology that you are selling. An operating system is a great example for that, because if you sell a server, people will need an operating system in order to sell your server. And the idea of commoditize your complement is that you want that complement, the software, for example, if you're selling hardware, you want the software to be as cheap as possible for two reasons. The first reason is that IT departments have a certain budget to spend on new servers, for example. And the cheaper the software is for that server, the larger amount of the budget they can spend on the hardware. The second reason why it's useful to commoditize your complement, to make it so that the complement is as cheap as possible, is that if a certain business has a maximum budget for servers, for example, if you reduce the cost of the software on your server, there will be a whole bunch of businesses that normally wouldn't be able to afford your servers, but now can, because they don't need to buy expensive software anymore. Linux is a great example of this, because before Linux entered the market, a lot of these hardware developers, they had to also sell Unix licenses together with the hardware. But Unix licenses were incredibly expensive, prohibitively expensive. You could easily pay a few $1,000,000 for a license for Unix. And so when Linux came into the space, a lot of these hardware manufacturers started investing in Linux very, very quickly, because suddenly all these companies could then spend these millions that they were normally spending on a simple operating system. They could spend these millions on new hardware instead of on the software. This is one of the big reasons why you see so many of these large companies funding so many open source projects. For example, think about why Google, Amazon, and NVIDIA are all investing millions into an open source AI model repository. Well, it's because they're the ones selling the GPU compute power in order to run these models. If the only cost of running an AI model is in the hardware, then a lot of more of that money goes to Google, Amazon, and NVIDIA, because they're the ones selling the hardware and renting out the hardware. than if AI models themselves would be prohibitively expensive. This is also why Twitch is a premier sponsor of the OBS project. OBS project is an application that streamers use in order to stream their games. The less money streamers need to pay in order to start streaming, the more streamers will exist and the more business Twitch will have. And you see like a very large amount of the news articles you see pass by that are about a large company funding open source projects. It is behind the headline is this idea of commoditizing the company's complements. A third reason why companies reduce their IT skills gap, why companies invest in open source, is to reduce their IT skills gap. Using open source software inside of your business can really reduce the IT skills gap, for example, by speeding up onboarding. If all the internal software that your company is using is software that's being developed inside of the company and only used inside of that company, then every single time you hire a new developer, the developer will need to relearn everything about that software. However, if you build on top of open source software, then the developers coming into your company, a lot of the developers might already have experience with that software. And so the onboarding goes a lot quicker. It's the same with the hiring pool. A lot of companies use open source software internally in order to have a larger pool of candidates in order to hire from, and also to improve the hiring process. A big example of that is Facebook, for example. Facebook, a few years ago, they open sourced their chef cookbooks. So chef cookbooks are internal automation infrastructure to manage servers. And Facebook open sourced their chef cookbooks, and in an interview, they explained some of the reasons why they did that. And they said one of the reasons why they do that is because Facebook is constantly looking for new people to help them manage their infrastructure, to help them automate their infrastructure. And from the moment they put these things online, community volunteers started contributing to this software. And so they immediately saw who was competent and who had the skills in order to work on this infrastructure. And so some of the best community contributors to the chef cookbooks of Facebook then got hired by Facebook and are now working at Facebook in order to help build their infrastructure. It's the same, for example, with collaboration. DreamWorks, the movie company, recently published one of their renderers as open source software. And one of the reasons they explained for that is that they use a lot of contractors. They use a lot of contractors in order to create the movies. And the issue was that the contractors, they had the onboarding process for these contractors was incredibly long because they had to really delve deep into this closed source internal code base of DreamWorks that nobody externally had any experience with. However, now that they've open sourced their renderer software, a lot of the contractors that come in and start to help DreamWorks with new movies, they actually come in and already have experience with their software because they've been using their open source software and they've been contributing to their open source software before they were even hired by DreamWorks. So in summary, one of the reasons why companies create software for free is because software is not their main product, but hardware is. For example, Samsung and Apple create open source software because they want to sell hardware, or because world domination is. Google has so many different services that they want to sell, and the way how they sell it is by using open source software. Or hardware is why so many companies are investing in Linux or building cutting edge technologies, and they want more people who can actually help them build cutting edge technology. So now let's look at the second reason why companies create open source software for free. And specifically, that's companies that create open source software and sell this open source software. But before we get to that, we will do a short break. Let's say we do a break of 10 minutes. So at 10:55, I will come back with the second part of this presentation.
Great. Thank you, Merlijn, for this first part. And maybe this is a good time also to ask the participants or the attendees here if they have any question. They can write it in the chat or in the QA section, and we will answer to that after the break.
All right, welcome back, everyone.
Maybe a quick question that I might have, since you gave a nice perspective on how big the open source world is and how useful it is in the end. Perhaps one question would be, if someone would like to start contributing or helping in this open source world, what would you recommend as the initial steps to get used and to get acquainted to this world?
It's a good question, but it's often a complicated question because it depends a lot on on what your interests are, on where you are in the world. For example, if you just look at the Ubuntu community as a project, figuring out where exactly to contribute in the Ubuntu community, it's a very complex project. And so what we often see is that often people either go to a local community. Ubuntu has this concept of local communities, which are local groups based on the country, or even in the US, for example, based on a certain state or a certain area, of people who are all interested in Ubuntu and who come together physically in order to talk about their interests and maybe help each other contribute to open source software. Another thing we often see people do is that they start out with actually community support. That's also how I started out. I started out by, I was interested in Ubuntu, so I installed Ubuntu on my laptop and a bunch of stuff didn't work. And so I went to Ask Ubuntu to ask for help. And then at a certain point, I saw on Ask Ubuntu, I saw somebody else ask a question. And I was like, oh, wait, I can actually answer this question. And so I started answering questions on Ask Ubuntu. And that's how I started in the Ubuntu ecosystem. Because answering questions, it's often, because there's such a diverse array of questions that people can have, there's often always some questions that you can still answer. But figuring out how to answer these questions, it often gives you a lot of experience with the actual tools. And so then we see people, then they evolve from simply answering questions to actually, if a certain question is a bug, then they can actually start to try to fix that bug and change the code in order to fix it. However, we also see people who are using a certain open source product, and they discover a bug, and they just go to the code and start diving deep into the code and try to fix that bug. You also have people for whom that is their first introduction into open source software. But I would say for many people, one of the most important parts is to find a community that actually helps you. Find a community that you like, because there are a lot of different types of communities in the open source world. Some are very professional, like the Kubernetes community, for example. Others are less professional, more community-based, like Ubuntu, for example. And then some are almost 100% volunteer-based, a very laid-back environment. And so, depending on what you actually like, what kind of community you like, you can just interact with a certain community a little bit. And then when you find like, oh, this might not be the thing for me, well, then you just go to another open source project and interact with the other community. Because if the community is something that really clicks with you, if you and the community match, then you will probably stay there for a long time. And it doesn't even matter whether or not you start out by actually contributing. You can also just start out by just talking to people. But if you stay in that community for a certain period of time, you will get a lot of knowledge and you will start to actually contribute.
Great. Thank you, Merlijn.
So for the second part of this presentation, I will dive a little bit deeper into the business models of selling open source software. As I said in the beginning, this is an interesting topic because as a user of open source software, it's often important to have some sense of the company behind this piece of open source software. What is their business model? What is their long-term strategy? And does that fit into how we are using this open source software? For example, some businesses, their strategy for open source software is to at some point get acquired by a much larger company. If you have a if you are in a very low risk business environment, in a business environment has very low tolerance for risk, then maybe hold off on those pieces of software, because once these companies get acquired, you don't actually know whether or not the strategies and values of the parent company will still align with the strategy that you that the piece of open source software is part of. But first, in order to talk a little bit about how the business models of these companies, it's important to give a short introduction in intellectual property law, because that's very important for these business models. So there's basically three ways that a company can protect software intellectual property. The first one is using copyright. Copyright is open source software, open source licenses, they all fall under the copyright umbrella. Copyright is basically the permission to copy, reproduce, and modify a work. In traditional environments, that's publishing a book and showing a movie, for example. With software, that is distributing software, running software, that's all under the umbrella of copyright. The second way is using patents. With a patent, you give permission to use a certain invention. For example, the light bulb was a patent. The MP4 video decoding algorithm, there's also patents underneath that. Even if you have open source software that allows you to decode an MP4 file, you still need to pay in order to run that software, because that software is patent encumbered. That software does certain actions that are protected by a patent. And then the final one is our trademarks. It's basically the permission to use a name and a logo. In traditional environments, in the in the clothing manufacturers, for example, they really use this a lot. Nike and Adidas, for example, the way that they increase the value of the clothes that they produce, it's by putting their logo on it. And other people are still allowed to create the exact same shoe, but they have to remove the Nike and Adidas logos. And so that's how they actually make money. And that's also how Ubuntu makes money. And so that is a nice segue into the first business model of open source software. And that's basically selling a trademark. So the software itself is open source, but people are not allowed to call it Ubuntu. Ubuntu itself, the code base itself is open source. All the code is open source. The binaries are open source in the sense that anybody can use it, distribute it for free without having to pay anything. But there are a lot of restrictions on what you are allowed to call Ubuntu. So for example, Microsoft has this functionality on Windows that is called Windows Subsystem for Linux that allows you to run Ubuntu on top of Windows. The Ubuntu that is running on top of Windows, it is not the default image provided by Canonical, the creators of Ubuntu. And normally, a company would not be allowed to call that Ubuntu. Normally, the only thing you're allowed to call Ubuntu is the specific image that Canonical provides on their servers. And so an Ubuntu distribution that is changed in order to make it run perfectly on top of Windows, normally Microsoft should call that a different name. They should strip all the trademarks from the software and call it a different name. But the issue is that Ubuntu is such a strong name. A lot of developers, they don't want to run something that is Debian compatible. They just want to run Ubuntu because that's the name they know, that's running on their servers, and so that's what they want on their laptops in order to develop the software. And so that's why Microsoft pays Canonical in order for their modified version of Ubuntu that runs on Windows, in order to call that Ubuntu. It's the same with Amazon, Google, and Dell. They all pay Canonical not to be able to use the software, but to be able to call the software by the name of the distribution. That's a very common approach for selling open source software. A second strategy is to sell packages. So the source code itself is open source, but what you pay for is a very easy way to install that software onto your computer and a very easy way to update that software. Red Hat, for example, is selling Red Hat Enterprise Linux licenses, and the source code is completely open source. Red Hat has a policy that all the source code that is in Red Hat Enterprise Linux has to be open source. But companies pay for the binaries. Companies pay for the thing that they actually install on their laptops and on their servers. It's the same with Ubuntu. Another strategy for Canonical to monetize Ubuntu is by selling live kernel patches. This is basically an update mechanism that can update the most low-level parts of your operating system without having to reboot. These patches are completely open source, but you pay for the service of packaging and testing these packages and then sending them to you so that your server can easily update them for the moment when they become available. But then the question is, why would people pay Red Hat for Red Hat Enterprise Linux instead of paying, for example, instead of paying an alternative that says that they are compatible with Red Hat? Why would people pay for Ubuntu Live Patch service instead of an alternative service by a competitor that takes the exact same open source code, also packages it, and also sends it to you? Well, there's two reasons for that. The first reason is on the left, who are you going to call when stuff goes wrong? If you are using Red Hat Enterprise Linux on mission critical servers, who are you going to call when something fails? If you're using Red Hat Enterprise Linux, then you are going to call Red Hat, obviously. If you use one of the competitors of Enterprise Linux that are compatible, then you have the issue that if something goes wrong, you can't go to the experts in order to solve these things. You have to go to the vendor of your software. Same with Ubuntu Live Patch. The people who are the best at making sure that a live update of your system will not break your server, they are obviously the people who are creating the entire operating system. And so that's why we see that even though a lot of these commercial packages have open source and often free alternatives or cheaper alternatives available, a lot of companies still choose to go to the vendor of the actual operating system itself, the creator of the actual code itself, simply because that is who they trust in order to help them out when things go wrong. A second big important reason is certification and compliance. And this is why, for example, in a lot of enterprises, you see these enterprises using Red Hat OpenShift instead of Kubernetes. Even though Red Hat OpenShift, it is completely open source. Every single component of Red Hat OpenShift is open source. The code is available and anybody can run it for free. However, people still pay for Red Hat OpenShift because Red Hat certifies that distribution, that package. It certifies it for a lot of different certification bodies. For example, certain ISO standards, certain compliance standards, healthcare standards. There's like a very, very long list of certification of things that Red Hat OpenShift is certified for. And even though you can also use the same source code for free, companies still want these certifications, need to comply to certain specifications. And so that's why they go with the paid option, the commercial option, instead of going for open source, for completely free open source. A third reason is because the companies sell support and services. And here again, you see Ubuntu and Canonical. Also, this is a third avenue how they monetize Ubuntu. They basically sell support and they sell hardware enablement. Canonical, the company behind Ubuntu, is a large contributor to the Linux kernel, specifically in order to make the Linux kernel work on newer hardware. And this is because a lot of laptop vendors, for example, go to Canonical to ask them to update the Linux kernel so that it can run on the latest hardware. Same with Collabora, for example. Collabora is an open source consultancy company that basically gets paid in order to add new features to software. It's simply software consultancy. However, the end product, the thing that this consultancy creates, it's not commercial. It's not a proprietary license. It's open source licensed code, so that if you're not happy with Collabora, for example, later you can take the same source code, go to a different company, and have them update the code instead. Same with IBM, for example. IBM is an incredibly big contributor to open source software, and that's simply because IBM is being paid in order to solve problems. They're not being paid in order to create software. And so the software is just a secondary aspect of that. And by contributing and building on top of open source software, first of all, they have a much better long-term story to tell to their customers. And second of all, it makes it much more easier for IBM to deliver all the different services that they do, because they can stand on the shoulders of these open source giants. Fourth business model is to sell proprietary add-ons. This is what we call the open core business model. It's a hybrid business model where the core of your application is open source. This is often called the community version of your application. And then there are a few small features on top of that open source core that are enterprise focused features that are proprietary and that people have to pay for. A very common one, for example, is authentication. A lot of open source software that is being sold, for example, GitLab, the open source version of GitLab, it has its own authentication system and doesn't integrate with single sign-on. However, if you wanted to integrate with your enterprise's single sign-on service, if you want to integrate it with the Microsoft single sign-on, for example, then you can pay for the commercial version of GitLab, and that has a proprietary add-on that can integrate with single sign-on. Something else are audit logs and compliance logs. It's also a feature that are often part of the proprietary add-ons of open source, open core products. There's some very popular products and companies that do that. For example, GitLab, Docker, Mattermost, VS Code, and diagrams.net, which is a drawing application. Then another option is a non-commercial option. Basically, there are also some companies and some non-profit organizations that are creating open source software that don't directly sell this software to the users of the software. For example, some projects ask for donations. Other projects create commercial partnerships like Blender and OBS Studio with Twitch and with Epic Games, because these are tools that are used by streamers and these are tools that are used by game developers. And these game developers and these streamers, they are the supporting the main product of the other companies that are supporting Blender and OBS Studio. Or, as is the case with me, for example, and as it's the case with NixOS, for example, or they're funded by grants. A lot of my research work is funded by grants, by the European Commission, for example, in order to improve the competitiveness of Europe. And the European Commission has a policy that as much as possible of the software that we create has to be open source, because they've seen that open source software is the best way in order to improve the competitiveness of European companies. Same with Solid, for example. Solid is a piece of open source software that is is trying to be the next generation of web application framework, which is funded by the Flemish government, because the Flemish government sees this as one of the tools in order to make Flanders more innovative and in order to solve some of the problems that the Flemish government has. Now I'm going to do a deep dive in open source licenses. And this is a very important topic because depending on the open source license, you are or are not allowed to do certain things. When you use open source code in your product or in your business, it's very important to know which specific open source license you are using. Otherwise, you might come to unhappy realizations that the way that you're using this open source software is actually not compliant. There are more than 80 OSI approved open source licenses. So it's a very, very large spectrum of licenses out there. But each license can be interpreted based on 3 features. The first feature of the license is attribution. Attribution is a feature of a license that explains that people who use this open source software have to let their users know that they're using the open source software. So for example, if you go to the Facebook app on your phone and you go to the settings application and you go to I think it might be copyright or something, and then you go to licenses. There you will see a very, very large page of all the different pieces of open source software that Facebook is using inside of their Android app. I put a screenshot of that a screenshot of the app of Instagram specifically on the right there. If you go to Instagram and search long enough, you will find a section of Instagram that explains, hey, yeah, we're using all these different pieces of open source software, and those are all the licenses of these pieces of open source software. The reason why Instagram does this is because they are required to do so by the licenses of the open source software that they're using. A second feature of an open source license is copyleft. Copyleft means that any modifications that you make to the open source software also need to be open source. There's basically 3 variations of copyleft. The first one is strong copyleft, and that means that even if you use a single library inside of your closed source software, even if you use a single copyleft library in your software, you need to make your entire program open source. Weak copyleft is a little bit less stronger than that. Weak copyleft means that if your piece of software uses an open source library that has weak copyleft, your complete application doesn't need to be open source. However, if you ever modify that library itself, then it needs to be open source. So strong copyleft means if you use that library, the entire program needs to be open source. Weak copyleft means only your changes to that library needs to be open source, but the rest of your application can remain closed source. And then permissive. A permissive license is basically a license that says you don't have any obligation to make anything open source. You can change the open source software, you can put the open source software in closed source applications, and you don't need to make anything open source. And so a lot of the software that, for example, the Instagram app uses are permissively licensed. Because obviously, Facebook doesn't want to open source Instagram. Then the final feature of an open source license is a patent grant. A patent grant is basically the creators of the open source software telling you that if you use that open source software, that you automatically do not need to pay for any patents that the creator of the open source software has. For example, you have certain video decoding programs that are open source and that are being developed by the company that sells patent licenses also. These companies do that so that other people can very, very easily incorporate the video decoder libraries into their software, and they can change it and modify it. But every single time they use that software, they need to pay the company for a patent license in order to be able to use that patented functionality of the software. However, certain open source licenses also grant users of that software all the patents that might apply to the software. So let's take a look at some more licenses in order to make this a little bit more concrete. The Apache License 2.0 is a great example of a permissive license. The Apache License 2.0 is a completely permissive license, and that means that if your application uses any Apache licensed code, you do not need to open source your application. You do not need to open source your modifications to that code. And moreover, because the license has an explicit patent grant, you will never need to pay for any patents that the company creating the software has on the functionality of that software. This is why I highly recommend using the Apache license for software if you want as much people as possible to use your software, because companies will love it if your software uses the Apache licensed code, because then they are 100% sure that they will not need to pay for a software license, for a copyright license, and they will not need to pay for a patent grant. In the family of permissive licenses, you also have the MIT license. The MIT license is another permissive license. It's very similar to the Apache license, with the main difference that it doesn't have this patent grant. So if you use software that is MIT licensed, make sure that you have a good idea of what patents apply to this software. And even though you might be able to use the code for free, you might still need to pay for a patent. Then finally, another common permissive license is the BSD license. However, I do not recommend using this license. And the reason why I do not recommend using this license for your own software is because there is a lot of confusion between what the BSD license actually means. There are already at least 4 common BSD licenses that are all called the BSD license. An old one, a 3 clause, a 4 clause, and a 2 clause. And from a legal standpoint, there really isn't that much of a difference between these licenses. However, it creates a very confusing environment. And so if you are a software developer yourself and you're choosing which license to use for your software, I would recommend, if you want the maximum number of people to use your software, go for either the Apache license or the MIT license. Do not go for the BSD license. However, if you are a user of open source software, all 3 these licenses are great licenses. From a user standpoint, it doesn't really matter. The main thing you need to remember from a user standpoint is that MIT and BSD do not give you an explicit patent grant, so you might still need to pay for a patent license in order to use that software. That when we talk about copyleft licenses, the most well-known copyleft license is the GNU public license. It's also called the GPL. The GPL is a strong copyleft license. So if your application even uses only 2 lines of GPL code, your entire application will need to be open source. However, it doesn't have a patent grant, the GPL. There is also a weak copyleft variant, LGPL. A lot of libraries use the LGPL, and LGPL is basically a weak copyleft license in the sense that if you change the code of the library, you need to make your changes open source. However, if you use the library in your closed source application, the rest of your application can remain closed source. The only thing you need to make open source are the changes to that library itself. Then you also have the Eclipse public license. It's also a commonly used weak copyleft license that has a patent grant. Then you also have the Mozilla public license. It's also a weak copyleft license. So it's important to choose the right license when you're creating open source software. I have basically 3 recommendations to give. The first recommendation is that if the product or ecosystem already has a license, well, just use that license. There's often no need to actually change the license. If you use the same license as all the other software in the ecosystem, then your software will integrate very well into that ecosystem. However, if you're creating your own ecosystem, or if the product doesn't have a license or has only a closed source license, there's basically 2 options that I can recommend. The first option is if the goal of open sourcing the software is that as much people as possible use this software, then go for Apache 2.0. Apache 2.0 is a very popular license in the industry because of the patent grant, because it is very well written from a legal standpoint, and because it's very well known in the industry. A lot of the most popular open source software uses the Apache license. However, if you say, no, the goal of open sourcing the software is not that as much people as possible use my code. The goal of open sourcing the software is in order to actually have a business model that sells the software, for example, then go for a strong copyleft license, specifically the AGPL 3.0. AGPL 3.0 is a strong copyleft license that ensures that anyone using your open source code needs to open source the entire application that is using that code. Moreover, even if the company that is using your code only uses it in server-side software, they still need to open source their entire code base. That's why a lot of companies that use a dual licensing policy, a lot of those companies use AGPL 3.0 because it protects their IP. It's the best license to protect their IP. So let me talk a little bit about dual licensing. Dual licensing is basically a hybrid system between open source and a proprietary license, where you have a strong copyleft open source license that anyone can use for free. So anyone can use the code, your open source code, anyone can use that open source code for free, but if they change your code or if they use your code in their own product, they need to completely open source their own product. However, if a company wants to use your code in a proprietary product and doesn't want to open source their code base, then they can come to you and get a second commercial license available for a certain price. The commercial license allows them to use your code without actually having to share the source code of their own application. Dual licensing as a business strategy is most successful for open core business models. So GitLab, for example, GitLab has 2 offerings. The open source GitLab offering, which is completely open source, but is licensed with a strong copyleft license. So anyone changing GitLab or integrating GitLab into one of their products need to open source their own code base. However, you also have a commercial proprietary variant of GitLab that you can use for a certain price. And when you use it, you don't have to share your modifications to it, and you don't have to share the source code of applications that integrate with it. However, what's important to know as a creator of open source software that uses the dual licensing strategy is that it requires you to have a CLA. A CLA is a contributor license agreement. A contributor license agreement is something that developers of open source software sign, and they basically give the company who owns the open source software, they basically give that company a second very permissive license. So normally, as a developer, if you contribute to an open source project, you implicitly agree to give your code changes to the owner of the code base under the same license as the code base itself. So if the code base has an MIT license and you submit a patch to that code base, implicitly you give your code away under the MIT license. However, by signing a CLA, you give your code away under two licenses. The first license is the license, the open source license that the code base has. And the second license is a second license only to the company, only to the owners of the code, which is very specific, which is very permissive. There are a number of reasons why companies and organizations use a CLA. For example, the Eclipse Foundation requires any contributor to sign a CLA so that they can relicense your code once a new version of their own Eclipse license appears. Other projects like GNU, for example, they require you to sign a contributor license agreement so that GNU as an organization has ownership of this code and so that they can start lawsuits as the owner of the code. Because if somebody else is the owner of code, you cannot start a lawsuit as a company or as an organization. You cannot start a lawsuit about somebody else's problem. You can only start a lawsuit if somebody is infringing on your own copyright. And so that's why a lot of open source organizations still require a contributor license agreement so that they can start lawsuits basically on your behalf. And then finally, as I've said before, another reason why companies often require a CLA is because they want to actually sell your code using a dual licensing framework, for example. Now, as I've said in the beginning, I also want to give some context of why is open source software eating the world? Why is there so much open source software? Why is every single Android app, every single iPhone app, every single operating system, why is it full of open source software? What makes software so different than other things that it makes so much business sense to give away your software for free? One of the reasons is that software as a product is weird, because let's compare it with an apple. If Bob has one apple and Bob gives that apple to Alice, then Bob has 0 apples and Alice has 1 apple. But if Bob writes a piece of software and Bob gives the piece of software to Alice, then Bob has 1 piece of software and Alice has 1 piece of software. Basically, software allows you to give something without losing something. As a result, if the number of customers that are using your product without paying for it, that number is basically irrelevant to you as a company. It's irrelevant in the sense that if that number is 100 or 1 million, you will lose the same amount of money by creating the software, regardless of how many people are using your software for free. And so, as a result, software development can still be profitable even if only 1 in 10,000 users actually pays for it. And that's where a lot of these open source business models come from. Free software means more users, and even if only a very small percentage of your users are paying users, that doesn't really matter, because you only have to pay to develop the software once, regardless of how many people are using it. And so more users is still better, even if only a small percentage of users are paying users. Because the more users you have, the more paying users you will have. Great example of this is MySQL, for example. In 2006, this is a long time ago, but it's very hard for companies to actually be open about these numbers. But MySQL in 2006 had 8 million active users, which at the time was 33% of the market share of databases. 33% of the total market share of databases, 8 million active users, but only 3,400 of those users were paying, but they still had $40 million in revenue. However, that $40 million in revenue was only 0.2% of the entire market share. MySQL, when they started out, they basically said in this pitch, we will take this billion-dollar market for databases. We will shrink it by a certain percentage by giving away a very good database for free, but we will capture a very small percentage point of the resulting market share as revenue for ourselves. Another interesting thing to realize about software is that tinkering with software is incredibly cheap. This means that if a volunteer wants to start creating or starts changing open source software, the only thing they need is a laptop. And if they create a software bug, well, then they often have a headache for a few minutes, start the debugger, start to find where that bug is, fix the bug, and a few minutes later, the bug is already fixed without the software even going into production. However, that's completely different from hardware. And thanks to SpaceX, we have some very beautiful visual representations of what happens when hardware has a bug. When hardware has a bug, there's often something like an explosion. And so if you are developing hardware and during the development process, you create a bug, you will lose a lot of money before you actually figure out what the bug is. And so because of that, developing software is much, much, much cheaper than developing hardware. Because of that, a lot of volunteers can actually help with developing software because, again, the only thing they need is their laptop, and they can even find bugs simply by running it on their laptop. As a result, there's so many volunteers writing open source software. With Linux, I think it's something like 20% of Linux kernel developers are actually doing it in their as volunteers as a hobby. Same with Python, same with OBS Studio, WordPress, VLC Media Player. These are all pieces of open source software that first started as somebody's hobby and then often became professional pieces of software, but that even as professional pieces of software, still there's a lot of hobbyists developing and contributing to that open source software. Another example is the Perseverance rover that's on Mars. Sadly, very recently, it broke one of the rotors, and so it's not functional at the moment anymore. And maybe it already happened, but very soon we will lose contact with the drone of the Perseverance, the Perseverance drone, because it can't fly anymore. But the hardware that is in that drone was mostly created by a global industrial complex and top-tier engineers. Some of the most cutting edge technology is in that drone. However, the software that is on that drone was mostly created by a bunch of nerds in their free time, because hardware is very, very complicated and requires a lot of investment, a lot of monetary investment in order to iterate on it and develop it and design it. While software, the only thing you need in order to develop software is a laptop. Another piece of context for why open source software is eating the world is that software maintenance is incredibly important, but also incredibly difficult. 80% of software development efforts are spent on maintaining software that already exists instead of writing software that solves the issue in the first place. So by developing open source software, you basically distribute the maintenance burden of this open source software over many different parties, often competitors. But it also forces the developers of the software to create code that is much easier to maintain. As an example, let's take a look at the Apache web server. This is a visual representation of how the different functions in the Apache web server connect with other functions. And this looks like a mess. This looks quite complex until you compare it with the Microsoft web server. So the Apache web server is an open source piece of product that's being developed by a group of volunteers and paid for developers all around the globe that are using mailing lists and asynchronous communication in order to collaborate. The Microsoft IIS web server is created by a bunch of developers in a single office in Seattle that if they have a certain question about a certain function, they can just get up out of their chairs, go to the desk of the colleague who wrote that function and ask them, what the fuck is this function doing? Can you please explain to me why this function is doing something so complex? And as a result, in order to merge certain code into the IIS web server, the barrier of entry is a lot lower, simply because the communication between the different developers is so much easier because they're literally sitting next to each other in an office. While with the Apache web server, if you write some code and then want to submit that code into the Apache web server, you need to have somebody else who reads your code, reviews it, and then commits it. That's the same with open source and closed source product. That's a very common way to work. However, with open source products, if the person merging your code doesn't understand your code simply by reading it, then the code will not get merged, because you can't quickly hop on a Zoom call, or you can't quickly go to that person and explain them face to face what that code is doing. No, the code has to explain it by themselves. And this is one of the reasons why we see that often open source software is much easier to maintain, simply because the way that open source software developers interact with each other requires software that explains itself instead of software that needs to be explained by a colleague. This is the exact same thing with the Linux kernel, for example. This is a map of the Linux kernel. This is already from 2007, but it looks quite similar this day. And this shows how the different components of the Linux kernel are separated and how these components interact. And the reason why we can put this in a nice diagram is because each box that you see corresponds with a single developer. So the way that Linux kernel development happens is that there is always a single developer or a single team of developers responsible for a certain interface, a certain subsystem. And so within this subsystem, if you want to change a piece of code within the subsystem, then you only need to get your code approved by one person, which is the head of that subsystem. However, if your code is interacting with code of other subsystems, then you need to get two people together and have them both agree that your change is a good change that should be added to your code base. And so because of this incentivizes developers to make sure that the different subsystems don't really interact with each other that much. Because every single time you write code that will interact with another subsystem, the development process becomes slower and becomes you will need more effort in order to actually merge your code. And so, interestingly, this is very similar to some of the lessons we can learn from the microservice paradigm. This is the exact same thing that these are the exact same incentives that microservice architecture wants to add to your organization. You have a whole bunch of isolated systems developed by different teams that only communicate over standardized interfaces. And when a certain team wants to change something in another microservice, they can't simply change the code in the other microservice. They need to ask the other team and then agree on a common interface, a standardized interface for these microservices to interact. Well, open source software has been doing this for a very, very long time, simply because of the incentives that the international open source development model gives you. Then, a final piece of context is that open source software allows you to stand on the shoulders of giants. Human brains haven't changed much in the past 40,000 years. The reason why society now looks completely different than society 40,000 years ago is not because humans have become smarter. The main difference is that we have collective knowledge that we gathered over 40,000 years, and we have great ways in order to actually give this knowledge to other people. It's the same with open source software. In 2011, a certain company did an estimation of how much money it would cost to redevelop the Linux kernel from scratch. And they discovered that it would take at least $3 billion in order to redevelop the Linux kernel from scratch. So, of course, if you are creating a certain piece of hardware and you need an operating system for that certain piece of hardware, it's much, much, much cheaper to invest a few $1 million in order to change the Linux kernel so it can run on your hardware than it is to do this $3 billion investment to redevelop a completely new kernel from scratch. This is the reason why the Linux kernel is so pervasive. And this is the reason why even in areas where that weren't really made for the Linux kernel, like real-time operating systems, the Linux kernel is still coming into those areas. And the Linux kernel is being changed in order to be able to also run in a real-time environment, simply because it's much more expensive to build your own real-time kernel than to just change the Linux kernel to turn it into a real-time kernel. If we look at the Linux Foundation projects in 2015, it increased to 5 billion. And so all this open source software has enormous momentum and has a very low cost to actually adopt it. And almost every single commercial user of this software improves a product in some way. For example, once Android started using the Linux kernel, first of all, the reason why Android was able to come to the market in such a quick time was because they didn't have to create this investment to develop a kernel. And then once the Android developers started changing the Linux kernel to work better on smartphones, one of the things they did was improve the power management of the Linux kernel. And interestingly, once this power management functionality was merged back into the Linux kernel, some high performance computers, some HPC centers, saw their energy bill drop by 30%, simply because the changes that were made to make the Linux kernel run better on smartphones were merged back into the Linux kernel. And so obviously, like this 30% improvement in power usage for their data centers was an incredible improvement, but the people using the Linux kernel and data centers, they didn't actually do the investment in order to have this improvement. This is this enormous momentum that these open source projects have. And this is why we see that once an open source project gets a foothold in a certain sector, in a certain area, often it's almost unstoppable, because every new user of that project actually also contributes to the project and improves the project and helps that momentum. Another example, at a certain point, Git was initially developed in order to develop the Linux kernel. Git is a piece of version control software. It's behind GitHub, for example, and it was initially developed in order to help develop the Linux kernel. At a certain point, Git became so good that Microsoft had no other option than to also switch to Git. But Microsoft had the issue that the entire Windows code base is a single code base, because they really have scenarios where a single engineer needs to make sweeping changes across the entire Windows code base, from the kernel to user space to the hypervisor. Some changes need a single person changing a bunch of files everywhere. And that means that the repository for Windows has 9 million files. This was something that Git couldn't handle at the moment. However, Microsoft invested a lot of time in order to add functionality to the Linux kernel, to add functionality to Git, in order to be able to handle repositories with 9 million files, and in order to be able to handle repositories of that large size. And so as a result, Git right now, it became even better simply because a company like Microsoft started using it. So, but then I've talked about how software is different than hardware. So then why are we also seeing more and more open hardware? Well, that has a very interesting source. Specifically, it's because Moore's law is failing. So Moore's law, it's this law that was said in the 70s or something, that the number of transistors in a chip will double every 2 years. This initially also corresponded to single thread performance. So every 2 years, a chip will be twice as fast as a chip of 2 years ago. However, over the past decade, we've slowly seen Moore's law fail. First, it started with single-threaded performance. Since the Pentium processors, single-threaded performance has hardly moved. All the advances in CPU speed were because CPUs became to have more and more and more different cores. So multi-threaded performance still kept increasing, but single-threaded performance since the 2010s has only increased a very, very a very small bit. However, even at this point, we're seeing that the latest chips simply don't have double the number of transistors every 2 years. And this has a big effect on the IT field as a whole. And one of the effects is that older processes and older designs still remain relevant. And that is one of the reasons why we see such a resurgence of open hardware. Things like the Raspberry Pi, for example. I think the initial Raspberry Pi is already like 10 years old, or even more than 10 years old. But still, the latest version of the Pi is just a gradual iteration, an evolution of the initial architecture of the initial Raspberry Pi. If you would have made something like this in the 90s, it would have never worked, because in the 90s, the difference between computers from the 1990s and the 2000s are so incredibly massive that it's simply not worth the effort in order to open source your hardware designs, keep improving the hardware designs, so that after 10 years, a lot of other companies can also use these designs. It's the same with RISC-V, which is a CPU architecture, an open source CPU architecture. The reason why RISC-V is starting to become relevant right now, even though the design is slightly outdated and it will take a long time for RISC-V to catch up to modern processors, it's still very, by the time it will catch up to modern processors, it will still be relevant, because hardware is simply not evolving at the breakneck speeds that it was in the past. There's a bunch of other things that are becoming much more important, like parallelization. That's why we see so much more usage of GPUs. That's why we see the microservice paradigms take off. That's why we see actor model and reactive programming take off. But one of the other effects of the end of Moore's law is that open hardware will also start to take off. So this was it, right on time. This was a short or a long but very broad introduction to open source software. If you're interested in knowing more about using open source software in your business for your cloud, for your journey to cloud computing, or for your journey to edge computing, or for your cloud native journey, please go to opencloudification.com to see all the other interesting webinars we have to offer. We also have interesting workshops to offer where we give you hands-on experience with some of the open source technologies. If you have any other questions, you can always ask them in the chat, or send me an email at my email address that you see on your screen right now.
Superb, Merlijn. That was a magnificent overview. We learned so many different things. We learned about your childhood. We learned about rockets and how they can explode, and how we could actually reuse some of the materials there. We've learned about legal frameworks, business models, technologies. It was really massively and amazing that you have been able to squeeze it into just under 2 hours. So I will have to do a bit of review in many of those elements to understand the grasp of it. But it was great to see in any case. So thank you for that. I'm not sure if there are any questions. I think you answered the question that I had in terms of what would you recommend to medium and small software companies when they would need to start the whole process of developing, and what type of open source licensing they would need to use. I think your suggestion was pretty clear. But I think there's a couple of specific mechanisms that, for instance, in some case, funding organizations like the European Commission are asking. And so is it then also that you recommend basically the Apache license as the baseline for this?
Indeed. It depends a lot on what the specific valorization strategy is of the piece of software. I've also seen some European projects use copyleft licenses specifically because they want to build a commercial framework around the software, a dual licensing framework. However, if the goal of the project is to create open source software that is used by the largest possible audience, so for example, if the goal of the project is to create internet technologies or base cybersecurity technologies that as much companies as possible should use, then I can definitely highly recommend the Apache license, because it's both very well known by developers, and also lawyers and legal personnel also really like the license because it's very well formed from a legal standpoint. And it has the patent grant. And so users of your software know that there's not this hidden cost that they suddenly will have to pay patent licenses. They can freely use your open source software without having to pay anything.
Okay, super. All right, Merlijn, thanks a lot again for this, and thanks also for the final suggestions and comments. And indeed, I hope people will pick it up and will continue asking us questions also in the next types of activities. I think this concludes this webinar in any case, and we'll be putting this also online. So looking forward to see you again in the next one. And that will be definitely on the key management in the cloud, how to best do that, and what some of the best experiences are there. So looking forward to seeing you again there, and thanks a lot for joining in, and stay tuned for our next activities as well.
All right, bye.
Bye-bye.